Okay, good morning class. Alright, so today we are going to continue with the third conics, hyperbola. So we have learned circle, ellipse and parabola. So today we were going to see the last conic, which is hyperbola. Alright, so what is hyperbola? So from here you can see that, okay, a hyperbola, again it has two definitions. All right, so the first one is a definition with the eccentricity. Still remember eccentricity? So means that the focus of a point which move such that so that the ratio of its distance from a fixed point, which is a focus, to its perpendicular distance from a fixed line is a constant. All right, which is the E. So so still remember this. When we define the ellipse, this one. All right, the definition are the same, just the different E, then you have different shape. All right, so remember, this is the focus F, right, and this is the fixed line, the directrix. Okay, so the ratio of its distance from the focus to and the perpendicular distance to the directrix, PF over PN, should be equals to E. And remember that when the E is between 0 to 1, then it is ellipse. All right, like this. When E is equals to 1, then it is parabola. All right, so when E is bigger than 1, then it become hyperbola. All right, which is this one. You see when the E is bigger than 1. So this is a definition of hyperbola, okay, with the definition of eccentricity. Okay, so a hyperbola is also defined as the locus of all the points on a plane such that for each point on the hyperbola, the absolute value of the difference of its distance from two fixed points is a constant. Okay, so this one means that same like the ellipse, we have two fixed points. All right, two fixed point, which is two focus. All right, so let's say this is a moving point. So the difference between the distance from the point to the two fixed point will be equals to a constant. All right, so remember when we learn about ellipse, okay, so the definition for ellipse is the sum of the moving point to two focus equals to a constant. You see, same diagram, moving point, two focus. But for ellipse, it is the sum of this distance equals to a constant. All right, for ellipse, it's the sum, you add. Okay, what else? For hyperbola, it is the difference. No, so means that the difference of the difference between the distance from the moving point to these two focus. All right, P F1, P F2. The difference means you minus. Okay, and why modulus? Because we don't know which one shorter, which one longer, right? It might become to become a negative number. That's why they put modulus. Okay, so the difference between these two distance will be equals to a constant. All right, so again I repeat, for ellipse is the sum of the distance. So for hyperbola, it is the difference of the distance. All right, so the two fixed points are called foci. All right, so the line passing through the foci is called the major axis. So it's actually quite similar to the ellipse, right? Whereas the midpoint of the foci will be the center of the hyperbola. So the straight line they're passing through the center of the hyperbola and perpendicular to the major axis, we call it conjugate axis. All right, so you can refer to the textbook page 232. Right, there's a diagram to explain this thing. So this is a diagram. Okay, so this is a hyperbola. So this is center. Okay, so the hyperbola is symmetrical about the major axis. This one, so symmetrical. Okay, and also the conjugate axis. So this is a conjugate axis. All right, and it's symmetrical. All right, and let's say this is the first position of the point. So P1. So you see P1 F1 minus P2 F2 equals to A. Then this is P2. Now let's say P move here. Then P2 F1, the difference between P2 F1 and P2 F2 also will be referred to the same constant. So this is the definition for hyperbola. So again, ellipse and hyperbola have two definitions. One by using the definition of eccentricity, which is the E. We find the ratio between the moving point to the focus and the perpendicular distance from the point to directrix. All right, and this ratio equals to E. So when E bigger than 1, it is hyperbola. Okay, and this is the second definition. We using the difference of the moving point to two focus. All right. So let's see how we can find the equation for the hyperbola. We see 5.1.4.1. A hyperbola with the center at the origin. So if the center at the origin, how's the formula look like? Okay, so to find the equation of the hyperbola with the center at the origin, okay, let's say P will be the moving point with coordinate xy. Assume that the foci are F1 and F2 because center is origin 0, 0. So the first focus will be negative C0 and the second focus will be F2 C0. Remember, they are the similar distance. Okay, and we will, and let's say this constant, the difference of these two distance is equals to a constant. Let's say this constant is 2a. So remember when we did ellipse, it's actually the same meaning. We use 2a because easier for our calculation. All right. So after that, we are going to use the definition for the hyperbola. The difference of these two distance will be equals to 2a. All right. Because this is modulus, right? So we know that to remove the modulus, it will become equals to positive a or negative a. Also, now we are taking 2a. So you see, you will get the same result if you use negative 2a. So if you want, you can try it on your own. All right. So for us, now we are discussing, we are using 2a. All right. And the solution, okay, how to find the equation is stated in your textbook. Okay, you can refer to your textbook, page 233. So you can open your textbook. Okay, page 233. So you see that. All right. The different D1, D2 lah, same as just now the PF1, PF2 equals to 2A. All right. So this is D1, this is D2. So use the formula for distance. So x minus negative c become x plus c lah. Y minus 0 is y lah. All right. Minus this one. This is for P F2. All right. So this is the formula. This is some formula for P F2. All right. Then as we say lah, we are using positive 2a. Okay, we use the positive one. So we shift these terms to the right hand side, become plus. All right, so the next step will be squaring both sides so that we can eliminate the square root. On left hand side, eliminate the square root and then we expand. Not to expand lah. This step not to expand. But this one square after square. So first term square is 4a square. This one square, no more square root. No more square root. And then 2 multiply this and this. So become this one. Alright. Then next step is we expand x plus c square. Alright. This one also expand. Then we can simplify, right? You see? X square no more. X square no more. C square, y square, c square, y square also no more. See that? Alright. So left, this one shift here, 4cx. This one shift here, minus 4a square. This left it here. So that we do the second time of, before this, we divided by 4a first. When this one divided by 4a, so 4 and 4 simplified, so it's cx over a. This one divided by 4a, left a. So this one divided by 4a, no more 4a lah. Okay, so after that, we square it, both sides. So squaring both sides, so when you square this one, elaborate lah. First term square, second term square, 2 multiply this and this. So a no more lah when 2 multiply this term and this term, a and a simplify. Alright, so this one square root square no more, so expand this x minus c square. Alright, plus y square. Okay, so you see we have x square here and x square here. So this x square, we shift it to this side and factorize out the x square. Alright, y square shift here. So minus 2cx no more. Okay, so c square is here, so we move the a square here. Okay, then divided this by c square, a square. Alright, so when this one divided by c square over a square, So means that you make this one as one fraction first. This part as one fraction. So when this one divided by c square x square, no more lor, cancel. So left x square only. So y square will be this one divided by c square minus a square, 1. Okay? Therefore, you get this, the equation of the hyperbola. Alright? But normally we write in this way lah. Okay? Where b square is actually c square minus a square. Alright? So you see that this formula very familiar, right? Of course. Okay? Of course, it's very familiar. So let's say with the center at origin, let's compare. So for circle, it will be x squared plus y squared equals r squared. This is circle for all the center at origin. Alright, so where else ellipse will be x squared over a squared plus y squared over b squared equals 1. So ellipse is plus. So this is hyperbola. So you see ellipse and hyperbola, all the three terms same, but it is minus. Alright? Okay, so this is how we get this equation, the standard form of the equation of the hyperbola. Alright? So you can refer to your textbook, page 233, to see all this solution. Okay? So you see, this is how we get this equation. So this is a standard form of the equation of hyperbola, where b square is c square minus a square. Where is the c? C is this one, the focus. Alright? Okay, so by arranging the terms, take y square as the subject. So we rearrange, means we rearrange this one, take y square as the subject. Alright? Then you see that what will happen. So I show it here. Okay, so I show it here. How to rearrange it. Okay, so this is the standard form of the equation. Okay, next step, because we want to choose y square as subject, so I move y square here, so the 1 I shift it here. Alright, so I make this one as one fraction. Okay, so I want to make y square as subject, so b square shift here. So it's b square over a square, then bracket x square minus a square. Alright, so why we want to arrange in this form? Let's see what will happen. So we know that for all the real numbers, y square, a square, b square will be always more or equals 0, right? After square. Remember the non-zero property. Okay? Therefore, if this is always positive, this is also always positive. Means this one also must be always more or equals 0. Alright? Then only tally. Okay, so we factorize this one, become like this, x minus a, x plus a. So let's sketch the diagram. So the roots are negative a and a. So positive means these two areas. So from here you see that x less or equals negative a or x more than a. So it means that the graph, let's open it. Okay, so it means that the graph does not exist at x between negative a and a. Alright, so this one show you where the graph exists, the region of the existence of the graph. Alright, so the graph will only exist for x less than negative a and more than a. Less or equals more or equals lah. So the graph does not exist between here. So this one no equal sign because equal sign here already. And these are the vertex, because these are the vertex, so they have the equal sign here. Alright, so this is the graph. See? Because the center is the origin, x-axis, y-axis, so the hyperbola looks like this. Alright? So, and the question say, right, x is axis less or equals negative a, so means that this vertex is negative a, and this vertex is a. Focus is here. Okay? Focus is C. Right? Focus is C. So, plus minus a, negative a, positive a is the vertices. We call it vertices of the hyperbola. Okay? Then, after that, you see, when x approach to positive, negative, infinity, when x, because going this side, going to this side, so negative infinity, positive infinity. Alright, so A become nothing lor, because x very big ma. Oh, so A compared to infinity, A is very small until we can omit it, right? So x squared minus A squared is actually approaching x squared. So this one, like, we can just ignore it. All right, so if this happen, then from this, okay, from this one, so y will approach, y squared will approach b squared a squared x squared, huh? Because this thing approach to x squared ma, this terms approach to x squared. All right, so y squared will approach to b squared over a squared x squared. So all cap square, then we can square root both sides. Then y is approaching plus minus b over a x. All right, y approaching, so means the graph approach to these two lines, plus positive b over x and negative b over x. And these two actually are the asymptote, these two lines. Y equals positive negative b over ax. These two lines are the asymptote of the graph. Means it's something like this. The asymptote must pass through the center lah. Okay, so these two are the asymptote. The graph won't touch these two lines. All right, so this is how we get the asymptote. Okay, so I hope you understand this concept. All right, so what I explained just now is related to number 4 lah. And also this one, how we get this asymptote, y equals plus minus b over a x. Okay, so same like ellipse. Ellipse we have horizontal and also vertical, right? So hyperbola also the same. All right, hyperbola also have horizontal or vertical, okay, which is like this. Okay, so I repeat. All right, I repeat one thing, which is for hyperbola. Remember, for hyperbola, how we determine whether it is vertical, horizontal or vertical? For ellipse, so ellipse is x squared over a squared plus y squared over b squared equals 1. This is ellipse. Okay, how we determine it is horizontal or vertical? So we look at A and B, right? If A is bigger than B, A is below this one, so it's horizontal, right? If B is bigger than A, then it's vertical. Remember, this is for ellipse. But for hyperbola, we don't look at this. Okay, because for hyperbola, it is minus, all right, negative. So we don't look at A bigger or B bigger. All right, what we look at? We look at which one is in front. Is x squared minus y squared or y squared minus x squared? Yeah, we don't consider A and B anymore. All right, so remember this. Okay, so if the hyperbola start with x squared first, so it's x squared over a squared minus b squared, y squared over b squared equals 1. If x squared minus y squared, then it is the horizontal one. It is the horizontal hyperbola. All right, where the foci is, because if this is horizontal, so means the major axis is the x-axis lah. This is, remember, still the center is the origin. So x-axis will be the major axis. So all the center vertices, foci, all lies on this x-axis. So we know that at x-axis, all the y are 0, you see. For the foci, y 0. For the vertices, you see, y also 0. Okay, so the foci will be negative c and positive c. All right, and c squared is a squared plus b squared lah. All right, and vertices will be negative a 0 and a 0. Okay, then the line segment AB is called the transverse axis. This one means the line join the two vertices. Okay, line AB, the line join the two vertices, we call it transverse axis. All right, and this transverse axis, the length is 2a. Remember, this is only true for if the center is at origin. All right, so it's like this. So the asymptote will be y equals plus minus b over a x. Okay, still remember latus rectum? So latus rectum is a line that passing through the focus. which perpendicular to the major axis and touch the hyperbola, this line. This is lattice rectum, and the length for the rectum is 2b squared over a. All right, and if we're talking about definition of eccentricity, then it involves directrix, right? Then it involves directrix. So the equation for the directrix will be x equals plus minus a squared over c. So this is for the first definition, by using the definition of electricity. All right. Other than this, these are using the second definition, which is we find the difference of the two distance equals to a constant. All right. So this table very important. Okay. So let's see some example. So the example, I only take example in your textbook, checkpoint 5.4. Page 236. Okay, page 236. So I'm going to discuss question 1. 236. Okay, this one. All right. Can see? Okay, question 1. This one. So sketch the following hyperbola. You're asking to sketch it. Then after sketch, find the vertices and foci. Then also the equation of the directrices and the asymptote. After you sketch, find these 4 information. All right. So I'm going to discuss 2 questions here. I'm going to discuss A and F. All right. So B, C, D, E will be your homework. All right. B, C, D, E will be your homework. All right. Okay. Okay, so we will always refer back to this table. So the first question. All right, so 1A is x squared over 12 minus y squared over 4 equals 1. All right, can see, so it's x squared minus y squared. So we know that it is horizontal. It is horizontal. And the vertex. Remember the vertex, which is A. Okay, which is A. So this is A squared. So the vertex is A, means square root 12. All right, so 12 is 4 times 2 ma. So square root 4 is 2 So 12 is 4 times 3. So square root 4 is 2 So 2 square root 3 This is your A. All right, this is to find your vertex A. All right, what else? To get C squared is 12 plus 4 A squared plus B squared ma. So 16. Okay, so we calculate this one first, then we sketch. So center is origin, because I only see x squared and y squared. So I know the center is origin. All right, the vertex is 2 square root 3 plus minus 2 square root 3. So it's horizontal. So this is the hyperbola. All right, then after sketch, they are asking to find the vertices, right? So V1 and V2 lah. 2 square root 3 and negative 2 square root 3, because it lies on the x-axis ma, so all the y are 0. All right, where else focus is C, negative plus minus C. So C squared is 16, so C is 4. So negative 4 and 4. All right, then next they need the directrix. Okay, so I continue here. All right, can see, okay. All right, okay, can see. All right. So to find the directrix, just use a formula here. All right, x equals plus minus a squared over c. Means the directrix can be here for ellipse. All right. So a squared over c. So this is a squared. A squared is 12. So c is 4. All right. So x equals plus minus 3. So means that the 2 vertical line, which is the directrix, is x equals 3 and x equals negative 3. All right, it will be somewhere here. Okay, so can be the left hand side, can be the right hand side. And asymptote. So this is the formula for asymptote. Plus minus b over ax. All right, so this is b squared. So b is square root 4 and square root 12. All right, square root 4 is 2. Okay. Hold on. B over A. A is 12. 12 is, oh, okay. I make a mistake here. It's supposed 2 square root 3. Follow this one. Yeah. Follow here. A. 2 square root 3. So 2 and 2 simplified. 2 and 2 simplified. So we rationalize the denominator. Multiply square root 3, square root 3. So it's square root 3 over 3. Okay, square root 3 over 3. So the asymptote is y equals square root 3 over 3x or y equals negative square root 3 over 3x. So means it's two line like this. Pass through the center if you want to draw lah. But if the question never asked, then not necessary. Alright, so these are the asymptote. Okay, so this is question 1A. So this is a horizontal one. Okay, then we will see another one, which is F. All right, I can see. Okay. So F, the question give you like this: y square minus 2x square equals 4. So when I see y square minus x square minus y square, this is definitely hyperbola. This is general form actually. So remember we have standard form and general form, right? So and then next we have to arrange it in standard form. So only we can get all the information that we want, right? So to arrange it in standard form, very simple. We know that the constant is the right hand side must be 1. So to make this one 1, the whole thing multiplied by 1 over 4. So this one y squared over 4. So 2 and 4 simplified, x squared over 2. So this one 1. So this is y squared minus x squared. So I know that it is a vertical one. It's just that simple. It's a vertical one. Alright, and the vertex will be B lah. The vertex will be B. So B squared is 4. So B is plus minus 2 lah. Plus minus 2. So these two are the vertices. So when we get the vertices and we know that it is vertical, so we can sketch already. Alright. Then we find C square. C square is A square plus B square, which one also can. So it's 6. So C is square root 6. Alright. So after we have sketched, then we find all the information they're asking. Also the vertex, because now the major axis is the y-axis. Vertical major axis is the y-axis. So all the center, vertices, focus, focus will be somewhere here. Okay, all lines on y-axis. So you see all the x coordinate are 0. Okay, so vertex V1 0 2, V2 0 negative 2. Okay, focus is 0 C so C square is 6. So C is square root 6 and negative square root 6. This one. Okay. Directrix again same. Follow directrix follow this one. Because just now it's horizontal, so the directrix is vertical. Now it's vertical, so the directrix will be horizontal. So horizontal is y equals vertical is x equals a number. Alright, so horizontal is y equals a number. So the number is plus minus b square over c. So b square c. Okay, so we multiply square root 6 over square root 6, then simplify. So you get two directrix. Y equals 2 over 3 square root 6 and negative 2 over 3 square root 6. It's somewhere here. Okay, and the asymptote. Alright, so you see that no matter it's vertical or horizontal, no matter it's horizontal or vertical, the equation of the asymptote are the same. Plus minus b over a x. Okay, so b is 2. X is square root 2. Alright, b is 2, x is square root 2. So to rationalize it, we multiply with square root 2 over square root 2. So this one times this one 2. 2 and 2 simplified. So left square root 2. Alright, so the asymptotes will be y equals square root 2x and y equals negative square root 2x. Must be passed through the center lah. So it's two straight lines, something like this. These are the asymptote. Okay. So I have discussed two questions, one horizontal, one vertical. Okay, so the rest you please do it as homework. Alright. Okay. So next we will continue As usual, we have learned the hyperbola with center origin. So again, we also will see what's the equation of the hyperbola with center h and k. Okay? So it's actually very similar lah. A equation of a hyperbola with center h and k is this one. Compared to this, just that become x minus h and y minus k squared. It's still minus. All right. So this is a standard form of the equation of hyperbola with center h and k. All right. Then since the center shift already from origin shift to some other points, so the most important thing is this 5 information also will change. Also memorize this table. Okay, so if x squared minus y squared, so again it is horizontal. Horizontal. So the transverse axis will be horizontal, or the major axis is a horizontal line, y equals k. Okay, center hk, as I said, from here we can see the center hk. Okay, the foci will be, so because it is all the center foci vertices lies on this line, y equals k. So you see all these 4 coordinates. Okay, all these coordinates, the y are the k. Only only x coordinate change. So for foci, h plus minus c, because the coordinate for focus is c ma. And vertices, h plus minus a. Alright? So the endpoint of the conjugate axis. What is the meaning of the endpoint of the conjugate axis? Alright, so for example, this one. Okay, for example, this is a major axis, right? Remember, this is a major axis. So this is a conjugate axis. Right? This is the conjugate axis. Okay, endpoints of the conjugate axis means these two. This is vertices. We draw 2 lines. Remember, this is a asymptote. So the endpoint means from this vertex, we draw a vertical line and touch these 2 asymptote. So this one also. Then we join these 2 points. You see, you become a rectangle. So these 2 we call the endpoint of the conjugate axis. Alright, because this is vertical ma. So the y coordinate, the x coordinate same lah. All the x coordinate same, only the k change, become plus minus b. Okay? So always remember, A is on the horizontal, B is on the vertical. Alright, so for the horizontal hyperbola, vertical hyperbola, y minus h. So this is a standard form. So the major axis is x equals h lah. A line, a vertical line, with the equation x equals h. Center hk, because it's all the focus center vertex lies on the vertical line x equals h. So the x coordinate will be always h only. So the only change is y coordinate. So y will be, for focus, y is k plus minus c. For vertices, is k plus minus b. Alright? And the endpoint of the conjugate, so means that it will become like this. It become you will get a rectangle like this. You will get a rectangle like this, right? So if this is B, then this is A lah. This is the endpoint of the conjugate axis. Alright? Okay, so this is a hyperbola with the center HK. So after you have learned circle and also ellipse, it's actually no problem to continue with this part. We are repeating the same steps. The only difference is the equation only. Alright? Okay, so the equation of the asymptote become this one. Alright, so the asymptote just now is center at the origin. Okay, if center is not the origin, so the equation of the asymptote become like this. Actually same. Just that this one become y minus k, this one x become x minus h. Alright, then when you're squaring the terms in this standard form, alright, mean expand it lah, and simplify it, then you will give us an equation in this form. This is the general form, you see. Okay, this is the general form where you will see x squared, y squared, x and y. Okay, all are real numbers, but A and B are opposite sign. A and B are opposite sign. Why? Because minus ma. Minus. So if A positive, B must be negative. If b positive, then a negative. It becomes y squared minus x squared. All right. Okay. So I hope that you can, after this, you can make yourself a summary. Okay. You list down all the characteristics for circle, ellipse, and hyperbola. All right. The standard form, the general form, the center, and all that. You make yourself a table to simplify circle, ellipse, and hyperbola. The fourth one then only parabola. No, because parabola is different compared to this thing, right? Because parabola only involve either x squared or y squared only. Right? Okay, then conversely, if we start with such equation, means if the question give you one in general form, all right, then you can do completing the square, like what we have done, completing the square and express it in this standard form. So that when it is in standard form, you will know the center, the vertices, the foci, all right, and all the others information that we need. Okay, an alternate way to sketch the asymptote. Just now we have done 2, right? In checkpoint 5.4, question 1. Okay, because that one is the center is origin, so very simple. It's very easy for us to get the vertex, then we can sketch already. Okay, so this is another alternate way to sketch the asymptote is A, yet we need the vertices. Okay, then find the 2 endpoints of the conjugate axis, means this one. That we draw the rectangle. Okay, the major axis is the vertex, then B here. All right, then when you join all these 4 points, you will get a rectangle. Okay, so this method is especially when you are asking to show the asymptotes. All right, so once you get the rectangle, so the diagonals of the rectangle will be the asymptote. Then you just sketch your ellipse. All right, so this method is especially when the question wants you to show or sketch the asymptote. Okay. So let's see. Example 5.1.4.2. Okay. So first question, sketch the following hyperbola. This one we can use this method. Okay, I will show you this method. All right. Okay. All right, like this easier to see. Okay, I will show you question 1A. All right, I want you to do 1B as homework. All right. So 1A, this is a question. Y minus 2 squared over 16 minus x minus 1 squared over 9 equals 1. It's y squared minus x squared. So I know that it is a vertical hyperbola. It's a vertical one. All right. So by using this method, very simple. We know that, it's my sketch. Okay, this is not correct. The axis is not correct. I sketched another one. Because this one, when you see y minus 2, x minus 1, so you know that it is actually not, the center is not origin, right? Okay, the center is not origin. Okay, so we will do again. 2 and 1. Okay, then shift up. Okay, so we will draw again. Okay, always label the xy axis. This is the origin. Okay, so from the equation, very clear. X is 1, y is 2. Okay, the center is 1 and 2. So let's say 1 is here, 2 is here. So this is the center of the hyperbola. All right, and it is y squared over y squared minus x squared. So I know it is a vertical one. So this is the major axis. Okay, this one will be your major axis. Okay, and then this one b squared. So b squared is 16. All right. Okay, b squared equals 16. So B is 4. Okay, B is 4. So means from here, add 4 units. So 3, 4, 5, 6. Okay, then from the center, minus 4 units. So 1, 2, 3, 4, which is negative 2. Yes, here. Okay, so we're very clear that this is a vertex. All right, but we want to draw the rectangle, right? So for the a square is 9, right? Okay, so a is plus minus 3, or horizontally plus minus 3. So center is here. So to the left 3 unit, 1, 2, 3, which is your negative 2 lah. From here also 3 units. So 3 unit means 1, 2, 3, 4 lah. Okay, so remember we draw the rectangle. We draw the rectangle through these 4 points. Yes. Okay, we draw the rectangle through these 4 points. And just how we say, right, the diagonal of the rectangle will be your asymptote. Okay, so this is the asymptote. Definitely go through the center of the the hyperbola lah. See? So these two are the asymptote, major axis. And this is the vertices. Okay, so from here you can sketch your hyperbola. Okay, so it's supposed like this lah. Okay, we are using the alternate method, right? So from the equation, okay, from the equation, we know our b square and a square. Center, mark the center, then b square to find b. So because this is vertical, so from center, move up and down 4 units to get the vertices. Then a is 3, so move left and right 2 units to get the conjugate end point of the conjugate axis. All right, then you sketch a rectangle through these 4 points. So the diagonal will be the asymptote. All right, it's a correct asymptote lah, not simply sketch. All right, then we know this is a vertex, right? Then you can sketch the ellipse by using this alternate method. All right. Okay, it's clear, right? Okay. So I want you to do 1B as homework. Okay, so next question 2. Okay, checkpoint 5.4. We go back to checkpoint 5.4. So I'm going to discuss some question for question 2, 3, and 4. Okay, so question 2, again, I'm going to discuss 2 questions. All right, so for those who don't have the textbook, okay, so I hope you can see it clearly lah. Okay, question 2, this one. Find the center, vertex, foci, and asymptote. You are given the equation. They want you to find all these 4 things. All right, so I'm going to discuss question A and C. I'm going to discuss A and C. All right, so please mark down in your textbook. So B and, I'm going to discuss A and C. So B and D will be your homework. All right, please mark down in your textbook. Okay, all right. So let's see B. Checkpoint 5.4, question 2A. Sorry, 2A. So you are given the equation in standard form, all right, of the hyperbola. So I rewrite it in complete way lah. So x minus 1 squared. So 4 I write as 2 squared. This one just y, right? So I write at 1 y minus 0 squared. And no denominator means denominator is 1. So this is a complete standard form. So from here, very clear. Center is x1 y 0. So center is 1, 0. All right, because this is x square minus y square. All right, so it's a vertical, x square minus y square. Sorry, I put it here. Can you see? Because I need to see the table. Okay, can see. Because I need to use this table. All right, so I know that it is a vertical one, x square minus y square. All right, so the vertices will be all the y same, so k plus minus h plus minus a. So this is h and k. So vertices will be h plus minus a, y-axis same. So 0, 0. Okay, and what is a? From the equation, a is 2, right? A is 2. Therefore, h plus minus 2. So h plus 2, 1 plus 2, 3. 1 minus 2, 1 plus 2, 3. Yes, 1 minus 2 is negative 1, sorry. So these are the two vertices, 3, 0 and negative 1, 0. All right, then where else for focus, we need C, right? For focus, we need C. So C square is A square plus B square ma. So A square, B square. So it's 5. Or C square is 5. So C is plus minus square root 5. And from here, the foci is H plus minus C. So Y coordinate same, which is still K. So the Y same as the center, 0. Okay, so H will plus minus C. So C is square root 5. So 1 plus square root 5, 1 minus square root 5. We express the answer in exact form. Don't use decimal. Okay, so the third one, they want you to find out, just now they want you to find out center, vertices, focus, foci, and the asymptote. So follow, this is the equation for the asymptote. All right, so just copy only. Y minus k, so means y y minus 0 this is y minus k y minus 0 equals plus minus b over x minus h, so x minus 1. Okay, b is 1, a is 2. All right. So k is 0 so y equals plus minus 1 over 2 b over a x minus 1. Like this only. So I expand it become 2 equation. Just when we take positive, multiply in, you get this. When you take negative half, multiply in, you get this. These two are the asymptote. Okay? Not difficult. Actually quite simple. All right. So question C. Okay? So C, the equation given is like this. Y minus 3 square, x plus 1 square. So y square minus x square. So I know that it's a vertical one. It's a vertical hyperbola. Okay, so I write it in a proper way. This one copy 4 is 2 square, 9 is 3 square. So it's the general form should be x minus h. This one plus means minus negative 1. Okay, so from here, very easy, we can get the center. So it's x negative 1, y 3. So this is the center. All right, and just now we say, this is a vertical one, right? So all the center vertices foci lies on the vertical line. So means their x are the same. Their x are the same. So same as the center. So you see center, the x is negative 1. So all the vertices, x is negative 1. Foci, x also negative 1. Only the y change. So y is k plus minus b. B is 2 So k is this one, 3. So 3 plus 2, 5. 3 minus 2, 1. So the vertices. All right. So for foci, we need c. So c square is a square plus b square. 4 plus 9, 13. So c is plus minus square root 13. All right. So it's k plus minus c. So k is 3. So 3 plus square root 13. 3 minus square root 13. Right? Very simple. Okay. So asymptote also the same. Y minus 3. X plus 1. Okay. B over a. So b is 2. A is 3. So 2 over 3. Alright, so I multiplied the whole thing by 3. So I get this. To eliminate the fraction, I don't want fraction. Alright, then the first one I take plus 2. Then I write it in general form. So this one I take negative 2. And I write it in general form. Just now this one I write in gradient form, right? This is gradient form. So this one I elaborate it in general form. or I elaborate it in general form. Okay, so I have done A and C. So remember, B and D will be your homework. Okay. So this is question 2. All right, then question 3. Question 3 is here. Okay, so question 3, I'm going to discuss one only because it's not difficult. Find the equation of the hyperbolas with the following foci and vertices. So they give you focus and vertices, the coordinate, and they want you to find the equation of foci in standard form. All right, so I'm going to discuss 3C. So please mark down. So A, B, D will be your homework. A, B, D will be your homework. Okay, so this is for question 3. Okay, so let's see. Like this easier. Okay, so for question 3C, you are given focus is 2, 3, 2, 9. Vertices is 2, 4, 2, 8. All right, so you see that all these 4 points, the x are the same. All right, x are the same. So I know that it is vertical. All the x are the same means the major axis is a vertical line. All right, where all the focus, vertices lies on the same vertical line. That's why x are the same. Also, I know that it is a vertical one. All right, so if it is a vertical one means it's y squared minus x squared, right? Vertical one, man. So it's y squared minus x squared. All right, and the vertices is k plus minus b. Focus is k plus minus c. So center. Center will be the midpoint of the vertices, right? Same lah. Either you define center as midpoint of the focus or midpoint of the vertices. Same. They will give you the same answer. So we know that center is midpoint of the vertices. I use vertices. Okay, so x definitely same. So center of 4 and 8. So 4 plus 8, 12. 12 divided by 2, 6. So I get the center already. All right, and vertices. So we know that the standard form for vertices are because it is vertical one. Vertices is k plus minus b ma. Okay, k is 6 ma. Right, k is 6. So 6 plus minus b. All right, and the two vertices given to us is 2, 4 and 2, 8, right? So what you think is b is? So 6 plus 2, 8 lor. 6 minus 2, 4 lor. So from here, you know that B is 2. Okay, right? Then how about C? Okay, C is 6 plus minus C. And the focus given to us is 2, 3, and 2, 9. 2, 3, and 2, 9. So what you think C is? So 6 plus 3, 9. 6 minus 3, 3. So from here, very clear that C is 3. Okay? You use all this. Okay? To find the value that you want. So after we have our HK, center, and AB, now you can form the equation already. Here. Okay, open it. Okay, so the center is 2, 6 ma. Okay, it's vertical, so it's y minus 6. Y is 6 ma. Y minus 6, then x minus 2. Okay, b square. B is 2, so b square is 4. All right, a square, yes, here. We have b square, we have b, we have c, so we can find a square lah. All right, the formula is c square equals a square plus b square ma. So c square is 9, b square is 4. Okay, so a square is 5. A square. Can? Not difficult, right? So first thing, from the information given to you, you determine whether it's vertical or horizontal. All right, then you determine the standard form. It's y square minus x square or x square minus y square. All right, then from the info given, you get either a square or b square lah. And then find C, focus, because focus given ma. Okay, then after that you can find another A or B. Then sub into the standard form. That's it. Okay, so this is question 3. All right. Okay, so question 4 also I'm going to discuss one question only. Because it's completing the square that we have done a lot lah, for center and for circle and ellipse. Okay, so show that the following equation represent hyperbolas. Or if you want to show that, you see it is given in general form. So they want you to show that it is hyperbola. So the only thing is you express it in standard form. Then it shows that it is a standard form of hyperbola. Then find their center, vertices, and the asymptote. Alright, so again, it has four questions there. So I am going to, let me see here. Okay, I'm going to discuss, where's my question? Okay. I'm going to discuss 4C. Alright, I'm going to discuss 4C. So again, please mark in your textbook, A, B, D will be your homework. Alright, A, B, D will be your homework. Okay? So this one related to completing the square. Okay. Alright. Can see, yeah? Okay. So you are given this equation, 9x squared minus 4x squared, 9x squared minus 4y squared plus 54x plus 16y plus 29 equals 0. Alright, so I see x squared minus y squared. So I know it is hyperbola. Okay, only hyperbola involved, negative. So same, we group x and x together, we group y together. Then the constant, we move it to the right hand side. Okay, so to do completing the square, this one must be 1, right? So I factorize out 9, become like this. This one also, I factorize out negative 4, so become like this. This one plus, so factorize negative means negative 4y here. The next step, completing the square. So x squared, 2 times 3 times x, 6x. So I have extra, 3 squared, 9. 9, so I have to minus out it. Okay, so this one also, y minus 2 squared. So y squared, 2 multiplied negative 2 y, negative 4y. So negative 2 squared, I have 1 extra 4. So I have to minus out the 4. Okay, so the 9 multiply in like this. The negative 4 multiply in like this. Okay, so minus 81 plus 16, shift it here, become 36. Alright, so standard form, the right hand side must be 1. So the whole equation multiplied by 1 over 36. Okay, so 9 and 36 simplified, 4. 4 simplified with 36, 9. So 36, 36, 1. Okay? So you make conclusion. This is the standard form. I forgot to write. You write yourself. Okay, so you just write. This is the standard form of the equation of a hyperbola. This is the standard form of the equation of a hyperbola. You show that it is hyperbola. Okay. Then the question wants you to find the center. Very simple. X is negative 3, y is 2. So center. Alright. So vertex. This is x squared minus y squared. Here. Okay. This is x squared minus y squared. This one. So the vertex is y, k same. H plus minus a. K same. So k is 2 so 2, 2, same. This is h plus minus a. A is 2 a squared is 4, so a is 2. So negative 3 plus 2, negative 1. Negative 3 minus 2, negative 5. So you find the vertices. Okay, so this question, they just want center and vertices. They don't want foci. They don't ask for, they didn't ask for foci, but they ask for asymptote. Alright, so just use this formula for asymptote. Alright, then I copy down the formula. So y minus 2, x plus 3. Plus minus BOA. B is 3, so 3 over 2. Okay, so when I take positive 3 over 2, then I write in general form. This is the equation. When I take negative 3 over 2, after we simplify, this is the general form of the asymptote. Okay, 2 asymptotes. Alright, so I think you have no problem with completing the square, right? Okay. All right, so we will see some past year question now. Okay. So I will discuss one past year question, STPM 2016, hyperbola. So you see that it's a very, very simple question. As I say, let's go back to the first page. Remember the first page? You see, hyperbola came out 1, 2, 3 times. 2013, 2016. Okay, 4 marks, and 2018, 10 marks. So this is a question, 4 marks question. This one. Very simple. So you are given the hyperbola in standard form. Okay, find the foci. Determine the asymptote. That's it. Okay, 4 marks. Alright, so I think no problem, right? It's like what we have discussed just now. Okay, so this is the solution. So you see y squared minus x squared. So it's a vertical. It's a vertical hyperbola. It's a vertical hyperbola. Alright? And this x and y doesn't minus anything. So center, origin. Okay? Center, origin. Very simple. Vertical, center, origin. Okay? So c squared is a squared plus b squared. A squared, b squared. So 64. So c is plus minus 8. Alright? Center is 0, 0. So vertical. So we know that the x are all 0. Okay? Only the y plus minus 8. So y also 0. So 0 plus minus 8. Foci. 2 marks. Okay? And it's actually using this one. Because center origin, this one, this table. Alright? So asymptote. Plus minus b over ax. B square root 48. A square root 16. So it's 4. So we know that 48 is 16 times 3. So square root 16 is 4. 4 square root 3. 4 square root 3, 4. So 4 and 4 simplified. Okay? Therefore, the asymptotes are y equals square root 3x and y equals negative square root 3x. Again, another 2 marks. Alright? Sometimes you can come up a very simple question like this. Okay? So, see or not? Yes. After you finish this video, please do question 4 STPM 2018 as quiz. Right after you finish this video, do question 4 STPM 2018 as your quiz and upload it to the Google Drive. I already prepared another Google Drive for this chapter 5. The Google Drive for chapter 5, the second one, because the first one quite many questions inside there already. Alright, so you forward in you upload it into the second Google Drive of chapter 5. Okay, so this is the question 4. Very simple. You are given hyperbola, general form. Find the standard form, 4 marks. Do completing the square. State the coordinate of the center and vertices. They want center and vertices. Then determine the equation of the asymptote. Show that the asymptotes are perpendicular to each other. How to show perpendicular? Still remember, two line perpendicular, you use the gradient. You multiply the gradient and you should get -1. Remember? And sketch the hyperbola. So this question give you 10 marks. Right? So if 10 marks is about 16 minutes long, you should take, okay? About 16 minutes to complete this. Alright, so don't take too much time to complete this thing. Alright, so okay, so I will stop here. Alright, for this morning. Okay, I will stop here for this morning. So after you have finished this, please do this as quiz. Alright, so the afternoon slot, I will do another short one for 5.1.4.3. Okay, I will do another short one for the rectangular hyperbola. This one will be the afternoon slot. All right? Okay. Thank you, class.